All right, Internet, long time no see. So what I want to share with you today is a concise version of a 3-part blog series that's focused on visuals. So what do I mean? So there's a blog series that published roughly 2 months ago that was called What We Learned Within a Year of Building with LLMs. And this is where 6 practitioners came together and they actually wrote this 3-part blog series. And in this, there was actually a lot of attention that was given to it. So this blog series is published on O'Reilly, and O'Reilly is pretty well known for courses and blogs and books that are related to technical topics. And this specific series actually garnered a lot of attention. So on Twitter and other places, or X, there was a lot of retweets and discussions around this blog series. Reason being is that these 6 authors are all practitioners. So they're actively building products with LLMs enabling them. And what I wanted to do in this video is actually kind of make this more concise and give you a TLDR version of it, making it more accessible. Reason being is that reading all 3 of these blogs in this series, it's around 42 pages of content. So not everybody's going to read that. So what I wanted to do here is actually create a visual representation of this blog series so you can actually take away the main insights that I thought were most interesting and hopefully utilize this in your own purpose of building out different types of LLMs in your products. So with that being said, I'm going to try to keep this tight, this video series. So we'll start with the first part is the TLDR of the TLDR. So this whole video and the blog that'll come with this video is a TLDR version of that 3-part blog series. And the TLDR here is simple. So if you look at the different things that one can do with with LLMs, you can break them down into categories, right? So down here we have a first part is prompt engineering. If we tack onto that, then we can add RAG and evals. Then the next level is self-hosting, and you can see this is all associated to complexity. So when you move across the horizontal axis, you actually increase in complexity. And this was actually mentioned as you move up each one of these areas of complexity, it's an order of magnitude, or at least an order of magnitude. And another thing that was stated in the blog is actually, if you just focus on these 2 categories of quality prompt engineering and quality RAG architecture and evals, you're likely going to get 80 to 90% of what you actually need to achieve the task you've set out to do. So sometimes you'll want to do self-hosting. We'll talk about that a little bit. But when it comes to fine-tuning and creating your own base model, that's usually something they've recommended to stray away from unless the specific use case matters most to you and you need that. So long story short is that you can get most of what you need from those first two categories, and you can ignore the rest to achieve the task likely you're trying to achieve with your LLM in your products. So that's the TLDR of the TLDR. Remember nothing else, remember that. All right, so I'm going to break this presentation into 3 sections, such as the blog series as well. So each blog is focused on certain categories. So the first blog they wrote is on tactics, next blog's on operations, and the last blog's on strategy. We're going to focus probably 80 to 90% of our attention on tactics. Reason being is that this is what most of you are likely going to get the most value from because you're building your own products today, and you need to know exactly what are the tactical things I can do today to improve the quality output of the LLMs I'm enabling my products with. So that's where we're going to focus. Up here in the right-hand corner. So up in the right-hand corner, you'll see that there's some beautiful icons. This is going to show you exactly where we are in our process. So if this is bright white, that means we're focusing about tactics. If this is bright white, we're talking about operations. If this is bright white, we're talking about strategy. So it's kind of your guide to the slides. Cool. All right, so first one's first is tactics. So this is around fine-tuning. And since we've already talked about complexity in the first slide of the TLDR, I wanted to bring that up again really quick to talk about complexity when it comes to fine-tuning. So oftentimes, when people embark on this journey of actually trying to fine-tune a model, they have certain expectations. So this is kind of the expectations they initially have. Of 90% of the progress can be made with prompt engineering, RAG, and evaluations. And then the last 10%, if you want to eke out the last 10%, it's likely going to be fine-tuning. But as you know, many builders have experienced this. When you're building something and you're trying to improve the quality of it, you realize that the last 10% looks kind of like this, where it's the last 10% is always the hardest to achieve due to the fact that either the complexity increases, the time needed to actually do something does, or other reasons. So this is a complexity kind of perspective of saying, if you really want to do fine-tuning, know that it's actually going to be a really long 10%, not just a small 10%. But with that being said, if you still want to do fine-tuning, these are some considerations you'll want to think about. So first and foremost is alternatives. Have you tried all the alternatives first? Have you thought through specifically the different prompt engineering tactics you're using So have you done quality prompt engineering? Do you have a quality RAG set up? And do you have quality eval set up to improve the model after each iteration? If you've already done this and you feel confident that you've done this well, and you've already tried all the alternatives, which are these, then you can move on to consistency. So the next thing is asking, okay, how important is consistency for my output? Do I need to ensure that 99% of what comes out of my model is consistent? If not, then maybe fine-tuning isn't a thing that I need to do for my use case. But if it is, then you might want to consider fine-tuning. And then lastly, I think this is probably the most important question, is what's the return on investment here? So if I know that likely I'm going to be confronted with this massive 10%, I want to ask myself the question, will I actually get a high quality return on investment from this effort? Meaning the use case that I'm creating around this model and the users that I'm trying to sell this use case to, is that going to be a high margin, or is that going to be a high profit I can derive from that model if I create it in the way that I want it to? So am I going to get enough money out of my users to actually pursue this path of fine-tuning? If not, then you should rethink it. And lastly, if you do want to pursue fine-tuning, data tends to be a big issue. So there's 2 recommendations in the blog. One is actually you should use synthetic data, meaning you have a model that actually creates data for you artificially. And also you can use open source data to bootstrap your fine-tuning process. So you're not necessarily having to create data from humans, which takes a lot of money and time. So that's the fine-tuning piece. That's the complexity piece. Next is prompt engineering. So these are the series of tactics they've mentioned that are used quite often when building out models and building out LLMs in your products. So first is few shot. So when you're interacting with a model, oftentimes the system prompt, which is the prompt prior to what the user experiences when they interact with your model, in that system prompt, you want to put a few shot examples in there. And few shot examples, usually you'll see people talk about it technically saying that you should have input-output pairs, but these 6 practitioners stated that actually output matters more than input. So if you want to just put in the ideal output of what the model should respond with in your system prompt as examples of saying this is ideally what you should be aiming for when you respond to the asks from the user, then you want to focus on the outputs. So you want to put ideal outputs or few shot examples for your model then to respond with. The number of examples that you want to provide to your LLM varies. So they've stated actually between 5 and a few dozen. So I've said between 5 and 24 examples is ideal depending on the use case you're pursuing. Oftentimes, if you go below 5, then your model can sometimes actually kind of hyper-focus on those examples, and the outputs are too kind of canned based off the examples you provided. So you want to give it enough examples that has a diverse understanding and a diverse output, but you don't want to have too many where you kind of overwhelm it. So the happy medium they found is between 5 and 24 examples for few-shot learning. All right, next is chain of thought. So this is a common tactic a lot of people use. So there's different levels to using chain of thought. So the basic level is simply tacking on at the end of your prompt, think step by step. This is the very basic version, level 1. The next step is actually offering up a sketchpad to the LLM. So in your system prompt, you actually want to say, I want you to think about a specific thing prior to responding, and I want you to think about it within the sketchpad provided, which is going to be likely XML tags. So XML tags would be basically adding brackets, and I think I know XML is mainly for Claude, and we'll talk about this in a second, but you can do this for GPT as well. So you want to put XML tags around your sketchpad you provide in the system prompt so it knows to actually do that within that section before it actually responds. And we'll talk about that in a second as well. So that gives it an opportunity to think through that piece. And then the next one is specific sketchpads. So this is the most advanced tactic they mentioned in the blog series. And this is where you offer up a sketchpad to the LLM in the system prompt, but you specify exactly what you want it to think about through each one of those sections. So you can say, I want you to first focus on extracting certain insights out of a piece. Then I want you to ensure those extracted insights match up with the thing that you've pulled it out of originally. So you make sure that it's consistent. And then after that, I want you to then write a summary based off of those insights in the overall transcript you pulled in. So you're basically breaking down exactly what you want it to do within the sketchpad instead of just saying to think about something. So this is a more specific version of the second option here. All right, cool. So the next one is setting boundaries. So this is also known as using delimiters. So delimiters is a common term used to actually put brackets around data sets. And this is important for a few reasons. And I'll actually give you, I think that's down there. So when you're talking to an LLM, either as a user or from an LLM to another LLM, which you can see in this visual here, it's important sometimes to ensure that the data that you're giving to the LLM there's a separation, because sometimes you'll put in a lot of data, right? And then maybe this chunk of the data, I don't know if you can see that, but maybe this chunk of the data here has a specific purpose, so purpose 1, and this chunk of the data here has a purpose, which is purpose 2. You want to ensure that when the LLM looks at this, when it's looking at this chunk of data, it knows exactly what each part of the data is used for. Example here is, say that I'm providing a bunch of text to an LLM. So say I provide an entire report to the LLM, but I also want to provide insights that I've derived from the report to the LLM as well. When I give that to the LLM, I want to ensure that the LLM can discern the difference between what the report is and what my insights are. So it can then do different things to each one of those data sets before it actually achieves this next task. And to do this, we use boundaries or delimiters, which can be XML tags, it can be JSON structures, or it can be Markdown. And the next animation in, you'll see that GPT actually prefers JSON and Markdown, Claude prefers XML. And this applies both to the input and the output. So when you look at the input here, this is the user ensuring the delimiters are set for the LLM. And then next we have this as an output. So sometimes we actually have a series of GPTs or LLMs that are strung together. So this LLM here, when it sends the output over to the next LLM to process, it will likely use delimiters. So that could be, like I said, it could be JSON, it could be XML, and that's an L, and then XML Markdown. So I'll do Markdown. So those are the three that we'll see put in there. And then the same thing applies here. So maybe we keep on doing that over and over and over. So that's the kind of the purpose and importance of this. Luckily, there are things that are already created for us. So for the commercial models, so this could be Claude, GPT, and others. Those actually have a Python library available that you can use. And this Python library is called Instructors, and this is mainly for commercial models. There's another Python library called Outlines for open source models. So this could be Llama, this could be, I think this is Quinn, and then this is Gemma from Google. And each one of these open source models, you can use this Python library. And these two libraries are useful for a specific reason, which is the output. So when we want to write a script, and that script basically allows each one of our LLMs to talk to each other. In that script, we want to import one of these libraries so we can ensure that the LLM, that when it responds to the next LLM, it includes these delimiters or these boundaries so the next LLM knows how to separate the data set. So that's the one of the important pieces they mentioned on boundaries. Next is prompt chaining. So this is one of my favorite things to do today. And I think this here is a quote kind of that we all want to, it's a mantra we should repeat to ourselves when we're creating these prompts, which is small tasks and clear objectives. And this is something that can be ported over from development or programming itself. And in this case, what we want to do is we have a massive big task that we want to achieve. And this big task should likely be broken up into smaller tasks. But oftentimes you won't realize this until you try and fail. And I've done this many times where I've given too many things to an LLM where it's a massive task and it's unable to actually provide a quality output because it's overwhelmed by how many things it has to do within such a small window of thinking and time. What we can do is we can actually break this task up. So in this example, let's say that we're actually doing meeting summaries. And for these meeting summaries, we wanted to do three primary things. We wanted to extract out the main key decisions, the owners of those key decisions, and any action items from the meeting transcript. Next, we want to check and ensure that the things that were extracted are connected to the transcript itself, ensuring that we're consistent with the data we pulled out. And then last, we want to create a summary of those key decisions, those actions, and also any key owners for that. And we can see each one of these are going to be an LLM in itself. So this can be the first LLM, the second, and then the third. Each of these are going to feed into each other. So once we've completed the extraction, we feed that into the next one, which does the check, feed that into the next one, which does the summary. And each one of these, when they work together in unison, that's called prompt chaining. So we're actually improving the ability for the LLMs to work collectively together to achieve a more accurate and or higher quality response based off of the task we've given it. All right, next is grounding. So this is part of the RAG section of the blog series. And grounding is a way to actually reduce hallucinations. You'll never be able to reduce hallucinations to nothing. Many of the best model providers today, the best they've stated they can get to is around 2%. And one of the primary ways of doing this is actually, it's a combination of both a RAG architecture and prompting the model to use that RAG architecture. So assume that you've already set up your RAG architecture, which is retrieval augmented generation. And what you're doing is you're pulling information from the database to ensure that the model is answering based off of that data and nothing else. And to do that, you want to prompt the model to do that. So say we have it set up, and we ask the model in our system prompt, and we're kind of setting it up, is that you should check this vector database And when you say you should check it first, or you should check it as the only thing. So either do this first and then check other things, or only check this and nothing else. Once you've checked the database to answer the question that's been provided by the user, then you either provide the answer back, or you say, I don't know, or something along those lines. By doing this, we're actually preventing the model from coming up with hallucinations and or pulling data from other sources that's irrelevant to the initial ask or out of the context the ask came from. So that's a form of grounding. The next one here is the combination of keyword search and semantic search. So you can see keyword search is still cool. And the reason I'm saying this is when semantic search became very popular around kind of the whole premise of LLMs, where a lot of people are using vector database to do semantic search, a lot of people assume that they can actually replace most search with this. And a quick summary of what this is semantic search is when you're looking for something, so say your user asks a question, and they ask a question in relation to a cat, but instead of calling it a cat, they call it a lion. What's going to happen is they're going to take that search, so we can say this is the text that's sent in. That text that goes in, it's going to go through an embedding process, and I didn't really spell it correctly, but that's all right. Embed, yeah. So it's going to be embedded. Once it's embedded, it's going to then go into this vector database. And this little icon here kind of gives you a good idea of it, where what we're doing is we're actually taking the semantic understanding of those words and looking for similar words associated to it. So these here are chunked together, these here are chunked together, and these here are chunked together. And you can see that each of these things have similarities to them. So for cat, if they're asking about a cat, but they've mentioned lion, we're likely going to see that the word cat here is closer to lion, which is closer to feline, which is closer to something else. And they're going to pull that back and respond with the information they pull from the vector database through semantic search. That's kind of what it is. Now, that's useful for semantic search. That's useful for vague things. So when somebody's using synonyms, hypernyms, other types of things that are maybe misspellings, and they send that in for an ask, you want to do the semantic search for that. But often, keyword search is important as well. So you want to do both. Reason being is that it's likely cheaper, faster, and more accurate to do keyword search if you're looking for a specific name, if you're looking for a specific identifier, or something else that's easily searchable within a NoSQL database. So the point here is that it's not or, but it's and. So you want to use both of these types of search when you're building out your RAG architecture. All right, evals. So when looking into LLMs, you'll see that over the last 6 months or so, there's a lot of discussion happening in relation to evaluations. So a lot of people that are deep into the space of LLMs and building these out, the importance of evaluations of your outputs and incrementally improving your output through evaluation is something that a lot of people are discussing and is very critical. But the issue here is that when you do evaluations for an output of an LLM, when you're evaluating the output to ensure that it's good or not, oftentimes you'll have to use humans manually, and that's really cost intensive and timely. And a way to mitigate that is actually using another LLM as the judge. So there's a lot of issues with this, but there's ways you can mitigate some of those issues. And the way this looks is very simple. So we have a user here. The user is going to input their question into the LLM. LLM is then going to respond. But before that response gets to our user, we're actually going to have somewhat of a batch process. So this isn't necessarily in the way. You can kind of see this seeing out of the way. So this is likely going to go back to the user, no blockage. What's going to happen is this LLM here, this is our evaluator LLM. It's going to take that output and it's going to evaluate it, saying, based off of the initial question, did we respond in a way that actually met their need? It's going to evaluate that. When it responds, they'll get the response, but over time they can actually take this whole batch of evaluations, because they'll add all these up. So we'll have a massive bucket of all these evals. We'll then feed this back into our LLM to improve its ability to actually respond. And that's kind of the importance and process. Now, like I said, there's different things you want to consider when doing evaluations. So the first thing is, instead of allowing the evaluator LLM to give a score, so a single score on a series of answers, you want to actually have it compare. And the way we do this is we actually have the response from the LLM to the user. So that's our answer 1. So that could be A. And then we have another response, B. So we have another response generated from a similar prompt, and we have different answers. Now, what we're going to do here is the evaluator is going to look at option A and option B, and it's going to decide which of these is better. And the reason we do comparisons instead of doing a score is there's a proven that it's actually much better. So the response from the evaluator is much more accurate and higher quality by doing a comparison instead of a single score. So we're going to compare answers instead of doing scores. Next is swapping. So when an evaluator looks at answers, so it's looking at A or B, oftentimes it favors a position, not the answer, which is quite strange. So if you give the same answers in A and B slots over and over, it might keep on choosing A because it just prefers position A. So what you want to do is you want to swap those. So you do it twice. You give it the answers, A and B. It analyzes the comparison, and then it swaps them. So you put B and A and B, and when you swap those, then the model will look at it again and choose the answer again. And if it chooses the same answer it chose initially, irrelevant of the position, you know that it's actually choosing the answer, not the position. That's another important thing to do. Another one is ties. So oftentimes two answers might be both very good, and you need to allow the LLM to tie. So if it thinks it's a tie, it should state that it's a tie. And the last is chain of thought. So this is when we have an evaluator LLM that actually thinks through its answer and provides you an explanation as to why it chose what it chose. And by doing this, we often actually improve the ability of the evaluator to reason. So it's important to allow it to do this as well. And another benefit for the chain of thought is when doing evaluations, you sometimes actually want to have a smaller model do this process. So you might want a small model here. Oh, I don't like green, and neither should you. All right, let's do that. Okay. So you want smaller models doing the evaluation. Reason being that you save money, you save time, and you save a series of other things. But also, when you do the small model in the chain of thought, you can actually get the same results from a small model as you would a large model because you're improving the quality of the small model's ability to evaluate something when you give it an opportunity to think through its answer before giving it back to you. So that is evaluations. All right, so next is on to operational stuff. So this one here is around moving prompts. When you move a prompt from one model to the next, there can be issues. So in this case, we have model 1 and model 2. So model 1, make this very clear, this is model 1, this is model 2. We're actually using prompt 1 and prompt 1. So we have two prompts that are identical. So we're basically moving one prompt from model 1 to model 2. And when you do this, the results differ drastically. Either they work in your favor or they work against you. Sometimes when you're upgrading models, so if you're going from GPT 3.5 to 4, you might actually get a better result. But sometimes when you switch models, you get a worse result. And that can be a massive issue with different reasons. So what we want to do is we want to actually mitigate the potential decline of our model's response when switching models with our prompt. So one approach is when you're using commercial models, such as OpenAI, Claude, etc., they offer you the ability to do pinning. So pinning is when you choose a very specific version of a model, and you say, I always want to utilize, say, GPT 3.5 version, blah, 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 blah. And anytime that there are updates that occur for either that version or other versions, you're not impacted because you're pinned specifically to this version. So that's one mitigation. That's actually a short-term mitigation, right? So the long-term mitigation is shadowing. And for shadowing, what we're going to do is we're going to do model shadowing, where we have in production, we have a specific model that is, that's our production model. So this is our production model, and this is model 1. And this is in our test environment, which should be identical to production, which isn't always the case, but we always try. We're going to have model 2. So this can be either just a completely different model or an upgraded version of model 1. In this process, we have our user. So we have our user here that's inputting their prompt. And when they input their prompt's actually going to go both to production and the test environment. And we're going to monitor the responses from both models over time. So we're not going to just watch one, but we're going to watch a series of responses. And over time, as we monitor these, if we can see that model 2 is actually better, or at least on par with model 1, then we have confidence in switching in the future. So this is a shadowing process where we can actually mitigate those issues in the future. All right, next is feedback. So when you want to get feedback from your users for multiple reasons. One is actually improving your model. So you have a user that inputs their question into your model, and your model then provides feedback or a response to it. Now we want to ask the user, has the response from the model kind of answered the question you asked? And there's different ways we can do this for seeking feedback. And when we seek this feedback, that feedback then is fed back into our model in the future. So we can actually improve our model over time through human feedback, our users, from what they care about. So when we can improve the model and make it better. There's two ways we can do this, implicitly and explicitly. I prefer implicitly because you actually get more feedback from the user that way. Reason being is that oftentimes when you're prompted with a survey, almost nobody fills it out. And if you're prompted with a thumbs up or thumbs down, you're likely not going to click. So you're likely going to get more responses if it's implicit. And then if it's explicit, sometimes you get responses, but it's also one of those things where actions speak louder than words for many users. So there's a few examples we can look at here. The first one on the implicit side is Microsoft's Copilot. So for Copilot, there's a series of things that they do to actually seek feedback. So one clear one is that when you use Copilot, you type in your function, and it then auto-completes for you. So the question is, did you accept that autocomplete? If you accepted it, that's a form of positive feedback. That's actually probably one of the strongest forms of feedback because you didn't alter anything. So that's the option one is basically accepting with no alteration. Next one is you accept it, but you then change some stuff. So you decided to make some changes to the code. So this is a positive one. So to say this is like plus plus, this is going to be positive. This is super positive. This is kind of positive. The next one is actually declining. So say you decline the code because it doesn't make sense and it's not good for you. This is negative feedback. This is all implicit from the user. So the user is actually giving feedback while they're doing their work without having to stop and do a survey. So next is Midjourney. So if you've at all used Midjourney, you'll know that with Midjourney, when you create an image, there's usually, I think, you can kind of choose how many, but there's usually 4 images or 2 images. And from this, say you get one image, so this image here, and you like it. So you actually click on this image, and then in there, there's additional options where you can actually upscale the image to improve the visuals of it. You can create variations of that image, and you can do other things. So upscaling, so if you have an image created, you look at it, you then upscale it. That, in a form, is a really strong response because you both like what they provided you and you upscaled it because you liked it so much. Another one is say you choose it and then you create a variation. So this is also positive, not as positive as this one, but it's still positive because we've taken what they provided, we've created a variation from it. And then another option here is basically just changing altogether. So say that they provide you 4 images, so 1, 2, 3, 4, you decide all these are bad and you do it again. When you do it again, that in a form is negative feedback. So we're saying that what you provided initially was bad, so we want to start over. So that's another form of implicit feedback examples for that. And then our last one here is explicit. So if you've used ChatGPT, I'm sure many of you have, with ChatGPT, there's usually a thumbs up and a thumbs down. And there's also options where basically it'll give you 2 responses. So when you ask it a question, it'll basically give you two options. So like option 1 and then option 2, and you can choose either one of these. When you choose one of this, you're giving implicit feedback in a way. So you're saying, oh, I like this response better than this one, so this is the one that gets the up feedback. This one gets negative feedback. And then for the up and down, you can give thumbs up and thumbs down on responses, which is explicit asks. So that's the feedback piece, and that's the importance of it. All right, next is downsizing. Oftentimes when you're experimenting with a use case, you're likely going to go to a large commercial model because you just want to see if it's feasible. You want to see, is it possible to actually achieve this task? Once I've tested that and I can see that it's possible, I immediately want to actually downsize to preferably either a smaller commercial model or an open source model. And you'll have to do additional work to ensure that the prompt you put into the smaller model actually achieves the same quality as the large model. But you want to do this for 2 main reasons. You want to have a faster latency. Usually smaller models are faster. And also you want to save money. And then also if it's open source, you can benefit from the privacy piece. So that's kind of the reason you want to downsize, and that's kind of the flow you want to do it through. And then there's another way of looking at this, a different lens of looking at this, is actually looking at it through the lens of a business or a product you're trying to create. So when you're creating a product or creating features for a product, you want to ensure that there's a strong product market fit with what you're creating. And to do this, you want to experiment. So you're going to experiment with these APIs, likely ChatGPT, Claude, Gemini, etc. And when you're experimenting with these, you're seeing, okay, the product I've created or the feature I've created, does this resonate with my users? Are they willing to actually pay for this? Are they going to use it a lot? Once you've established that there is a product market fit and you're really confident in that, you want to increase the profit margins. And to increase the profit margins for the product or feature you've just created, you want to, like I said, again, downsize or transition over to open source. Probably both. And like I said, by doing that, if you go to open source, you're going to self-host it yourself, so you can actually have faster latency, you can save money, and you can also not worry too much about privacy because you're likely hosting that in a place where it's not being pushed off to a LLM provider. So that's the product market fit important for scaling. And then this slide here is probably the second most or the most important slide, which when you're building a company around LLMs or you're tacking LLMs onto your company, it's important to think about what's the strategic moat that I'm putting here or creating. Oftentimes people think the strategic moat they're creating is their ability to swap models. So it's like depending on the feature I have, the quality of the response I have is directly related to the model. But that's not always the case. So your ability to swap models in and out between 4, 4.0, 3.5, etc. isn't really a strategic moat. What the moat is what you've built around that. And this can be broken into 4 categories. So we have, we'll start with guardrails. Ooh, that's ugly. All right, we'll start with guardrails. Now, with guardrails, This is really saying that when I have responses that I built out, the infrastructure I built from our guardrails for the response to the model, is it providing harmful information? So is it providing sexual information, criminal information, kind of violent information, etc.? You want to ensure that you can mitigate that with guardrails. Next is the data flywheel. So this is the feedback loop that I mentioned around explicit and implicit feedback. All that feedback we're getting back from our customers, we want to feed that back into our LLM so we can improve the LLM's response based off of the response that we received. Next is caching. So instead of actually going to the LLM in the first place, we want to cache as much information as possible that we feel like would be relevant to be pulled back into the response. So if we don't have to go to the LLM in the first place because somebody has already asked this question and our LLM's already responded, we can save on money and time by using caching. And then last is evaluation. So ensuring that you have strong evals in place and you're improving the model based on those evaluations over time. So by incorporating these 4 categories into your moat and really increasing the quality infrastructure for those, that's how you create the strategic moat, and that's the importance of making a durable company around LLMs and features associated. And with that being stated, I think those are all the slides. So internet, I appreciate the time. I hope this is useful, and I will see you. I'll see you next time.